A hemp war. This example will use 4 satellites or weapons. North Korea has already launched satellites into orbit. Polar orbits simply circle Earth from the North Pole to the South Pole. The satellite, or a warhead, will eventually pass over every country on the planet. Everything is relative. In this case, we watch the orbital path and see Earth rotate under it. The time length of the orbit coincides with continental America's 4 time zones. As these satellites pass over North America, I'll illustrate the threat. This is only phase 1 of the attack. This one must happen first. In this theoretical war, the enemy hits America with overlapping, powerful HIMPs. This will knock out Mexico and Canada as well as the USA. Reasons for using 4 warheads: using only one risks a dud or a misfire that is a low yield. A spread across the horizon will blind more people. Multiple HIMPs may overwhelm preventative measures. Phase 2 of the 3-step attack. None of the bursts over North America would create nuclear-pumped radiation belts. Hawaii is ideally located to be hit with all 3 high-altitude military effects. The U.S. military has simulated the latitudes, the warhead yields, and altitudes shown here. The radiation belt from just one of these bursts is lethal to the International Space Station in about 5 hours. These 3 bursts are spaced to place the fireball within direct sight but not overhead. Putting the fireballs above the horizon but below high noon and surrounding the islands will blind the most people. What could happen if the last missile is intercepted? Salvage, fusing, and some consequences. The interceptor missile causes the warhead to detonate right over the container ship launch point in Honolulu Harbor. A 4.4 megaton warhead detonating at 6 miles in altitude because of salvage fusing has a fireball over 2 miles in diameter. There is a sphere of lethal radiation 4.2 miles in diameter. Since radiation never reaches the ground, this type of detonation is a radioactively clean bomb. 6 miles high is too distant for devastating blast waves to travel. The blast will be felt on the ground, but is unlikely to cause serious damage. The heat can be loosely categorized by the damage it does. For instance, the heat inside this sphere is hot enough to make dry wood burst into flame. The heat inside this sphere will cause 3rd-degree burns on humans. This area is hot enough to cause 2nd-degree burns about 50% of the time. Heat within this sphere will cause 1st-degree burns, similar to a sunburn. We're looking at Oahu from a distant shoreline, far enough away to have a view of everything that happens. We'll eliminate the bottom half of the spheres. They're blocked by the ocean and the land. Flipping perspective once again, we look down on the heat zones from above. The detonation point is 6 miles high, directly over the port of Honolulu. This huge area covers almost the entire island. Exposed human skin will get 1st-degree burns. 1st-degree burn. The yellowish area indicates where humans will get 2nd-degree burn, about 1/2 of the island. This is a 2nd-degree burn. As distance from the fireball shrinks even more, we enter a zone where 3rd-degree burns are 100% certain. This is a 3rd-degree burn. This area is 3 times hotter than the last zone that caused 3rd-degree burns. A huge heat ray 14 miles in diameter cooks everything exposed. This is a 4th-degree burn. Remember, these burns happen to all exposed skin. Even 1st-degree burns on this much skin is painful, and it happens in seconds. Of course, a 2-mile diameter fireball that is only 6 miles away is going to blind a lot of people. People are going to be blind, howling in pain, with no idea what has happened to them. A nightmare experience that no one is currently expecting from a nuclear attack. Japan's successful weather balloon attacks during World War II were accomplished with 1940s technology. Adding in modern stealth, guidance technology, and salvage fusing, these weapons must be neutralized before they cross our borders.
At about 30,000 feet, under prevailing wind conditions reaching velocities of about 100 miles per hour, it takes approximately 4 days to make the crossing during the winter months, when wind velocities are highest.
The government suppressed news stories about this for fear of panic. You can see the jet stream in this NASA animation. Of course, balloons can be launched anywhere in Canada and Mexico, from offshore as well. Steering balloons in the stratosphere is a recent breakthrough. Focusing on the lower two layers will shift perspective. The greenish area is the end of the troposphere and the beginning of the stratosphere. Boundaries between layers are very indistinct and actually move up and down depending on conditions. This is the general assessment of where the source layer begins and ends. This is a weather balloon's natural domain. Winds are very high speed in the stratosphere and travel in different directions. As an example, a hemp balloon targets an area about 100 miles in diameter. With winds blowing at 100 miles per hour, passing a target will happen pretty quickly. To make the hemp as powerful as possible, the warhead needs to be near the top of the stratosphere. The balloon ascends to the top, but has to deal with winds blowing in different directions. Once the hemp balloon reaches the correct altitude and maintains position over the target, it can be detonated by the enemy, or it can wait for another event to trigger detonation. An attempt to destroy it would trigger salvage fusing. Balloons lose their buoyancy after a few weeks. This situation would also trigger detonation. Drifting too far away from the target can trigger detonation, preventing a defending nation from towing the weapon out to sea. A 100 KT warhead detonated at 20 kilometers, or 12 miles, altitude gives a retinal burn area that is huge, 300 miles in diameter. The target for the simulation is Chicago. This could happen if the defenders are trying to clear the skies of threats and a balloon is shot at the lowest altitude possible. According to studies done at the time of atmospheric nuclear tests, I'm showing you the worst case, which is a night burst when everyone has dark adjusted eyes. During daylight, the results are not as extreme, but that only shrinks the area affected by retinal burns. It doesn't eliminate the retinal burns. The more solid sphere is the area where people are guaranteed to get retinal burns if they are looking in the direction of the burst. The glowing hazy area around the sphere is where people will get flash blindness. I have no numbers on the range of flash blindness. 300 miles is the diameter. There will be very little EMP. Shooting the balloon down leaves only retinal burns and flash blindness as threats to the general population. In all, 7 balloons are used, detonating at 40 kilometers or 25 miles with a 100 KT warhead. Detonating at twice the height of the salvage fuse detonation, 40 kilometers versus 20 kilometers, more than doubles the area affected. This is the area of the hemp as well as the possible retinal burn area. This one covers New York, D.C., Philadelphia, Pittsburgh, Richmond, and Delaware. Indiana, half of Michigan, most of Illinois, half of Ohio, Milwaukee, and Madison, Wisconsin. Houston, Dallas, Austin, San Antonio, most of Louisiana. All of Arizona, San Diego, Tijuana, Las Vegas. All of Georgia, Tallahassee, all of Alabama, most of Tennessee, and South Carolina. All of Washington and Portland, Vancouver, Canada. All of Colorado, parts of neighboring states. Let's do some addition. 7 plus 4 plus 3 equals 14 warheads. 14 warheads is all it took to put America down. Whenever a nation becomes a nuclear power, it is an existential threat to America. These are the 10 chapters in this video series. I will continue to release more videos and video series on this complex subject.